All right, now let's go ahead and finish the 10-1. So in this video, we're going to be looking at password problems where we can utilize some of the ideas earlier in this section. Now here we're trying to come up with how many 4-digit passwords would be possible. Okay, so like PIN numbers you might use on your debit card, like 1141 or something like that. Digits mean numbers, and you've got the digits. There's 10 of them actually, because the digits would be a 0, 1, 2, 3, all the way up to 9. Those would be digits, single digit numbers that could be used for a password. All right, now we're going to look at several different scenarios, and I want you to imagine if you did the tree, but it's going to be way too big for you to actually do a tree, but to understand the shortcut you could use for this. So I want you to think about it like this. You're trying to create these 4-digit numbers, right? So I want you just to think that if you were doing the tree diagram, you have to look at the conditions here. So it's 4 digits. The first digit can't be 0. So that means I can't have a 0. I'd have to have a 1, then a 2, all the way down to 9. So the first digit could be 1 through 9. Now when I go to do my second digit, I have to pay attention to whether I'm allowed to repeat digits. And I am. So when I do my second one, there's no restriction on the second one. So it could be a 0, a 1, all the way down to 9. So there'd be 10 possibilities there. So I have 9 possibilities for the first one. And wouldn't it be true that for each of these, there'd be 10 possibilities for the second one all the way down? So this would be a uniform tree diagram if I were to draw it. Then off of the second digit, I would have 10 possibilities. And then off of the third digit, I would have 10 possibilities. And so the shortcut I could use to find out how many would be to multiply the number of ways, the number of options I have for the first place, the second place, the third place, and the fourth one, and just multiply that out. And I could make 9,000 different 4-digit passwords. Okay? So I can't draw the tree diagram, but I'm kind of thinking about it and the fact it would be uniform, and then just using the shortcut to find out how many there would be. All right, let's see this one. The first digit must be a 1 or a 2. Okay, so the first digit must be a 1 or a 2, but they are going to allow me to repeat digits. Okay, so it's still a 4-digit password. Think about your tree. It could only be a 1 or a 2 to start with, but then after that, I could have 0 or 1 all the way down to 9. And I could do the same here, couldn't I? So I'd have 2 possibilities for the first digit. Then I could have 10 possibilities for the second one. And there's no restriction on the third one or the fourth one either. And so I could create 2,000 different passwords. Okay? Now this one's interesting. The first digit must be a 1 or a 2, but this time repeated digits are not allowed. So let's think about how that would affect the tree diagram and how it would affect how many we wind up having. So when I do my first digit, I can't use just anything. It has to be a 1 or a 2. But when I go to do my second digit, since repeated digits are not allowed, I could have a 0, but I can't have a 1. So it'd be 0, 2, 3, all the way down to 9, right? So that means I would have not 10 possibilities, but 9 possibilities. So 2 possibilities for the first digit, and then whatever I used for the first spot, I can't use for the second spot. Repeated digits are not allowed. So then I'm down to 9 possibilities there. Okay, that would be true here. This would also have 9 branches. Could be followed by a 0 or a 1, but not a 2. You could have a 3, though, a 4, all the way down to 9. And it would be uniform because there'd be 9 here and 9 branches there. Okay? Now think about the next digit. Repeated digits aren't allowed, so 1 and 0 are not available. So for this one, it could be a 2 or a 3 all the way down to 9. So think about that. 2, 3, 4, 5, 6, 7, 8, 9 would be 8 possibilities now. See, I've already used up 2 of the digits. I'm down to only having 8. And that would be true for each of these. It would just be a different 8, but there'd be 8 possibilities here, 8 possibilities here. So it would turn out to be a uniform tree diagram, and I could just think how after I've picked my first and my second digits, I've used up 2 numbers, and so there'd only be 8 left. And then when I go to pick my fourth one, I've already used 3 digits, so there'd only be 7 left. And then you just multiply 2 times 9 times 8 times 7, and that would give you the 1008 possibilities. Okay, so that's password problems. They're a lot of fun.